Good morning. Thank you everybody for joining us post-party. It was a great hour of sleep I got last night, so I'm pleased to be here joining you this morning. We're here to talk about virtual volumes, and as you see, this is a technical panel where we're going to be discussing this architecture, this framework, this new means of delivering storage. And I'm very pleased to be joined by luminaries in the industry on stage here today. It's actually very, very pleasing to me to have this sort of level of commitment from such large companies to show how they are implementing this virtual volumes framework. So it is a technical discussion today. We'll be taking questions from the audience to be able to answer the questions that you probably have burning in your minds. I keep joking with people, and somebody made the comment actually yesterday that my session should be virtual volumes, all about virtual volumes, subtitle, ask your vendor. So this is your opportunity to ask your vendor of choice about how the specific details of Vvols will implement. So my name's Ken Werneberg. I run technical marketing for storage and availability at VMware, where I've been for a long time, since I was young and skinny. And I'll ask the panelists on stage with me here to introduce themselves down the line here as well.
Hi, I'm Raj. I'm a V specialist at EMC. I don't think I was ever young and skinny. So V specialists are just VMware geeks who happen to get their paycheck from EMC. So here to talk about Vvols and hopefully answer any questions you guys have around EMC's initiatives.
Good morning. My name is Paul Morrissey, Hitachi. I'm a director of product management. My team drives all the building all the V products, Vvols, VASA, and part of our UCP Converge team as well.
My name is David Glynn. I work in Dell Storage in the technical marketing role, but also half with engineering, which is wonderful because I get to sit down with the developers who actually create a lot of our products for VMware integration.
I'm Manish Jain. I'm with HP, soon to be Hewlett-Packard Enterprise. I'm technical marketing. And for the past year, all I've done is focus on the Vball integration that we have with 3PAR.
Hello, my name is Jean-François Marie. I'm Director for Product and Solution at NetApp in EMEA, marketing. So meaning marketing doesn't mean not technical. I've been an SC 9 years and a half at NetApp, installing things, tweaking things, gigging things. So I have a bit of knowledge of it. So I'm happy to be here and to give you some perspective at why Vball at NetApp.
Perfect. So I have a disclaimer, of course, that really I'm not going to legally bind anybody to anything that is said here on stage today, so feel free to communicate as we see fit. I'm going to assume a certain level of familiarity with virtual volumes, but just a very brief recap before we carry on with it. Virtual volumes is a framework that helps deliver on software-defined storage. This is a means by which VMware can extend the understanding of the VM nature, or the objects that that constitute a virtual machine, into the storage arrays provided by our partners in the industry here. So it's a means of delivering storage policy-based management, giving us per VM, very granular control through policy-oriented approaches to delivering data services from the storage to individual virtual machines. It is very much a framework. We provide a set of APIs that can be used to access these policies, to access the data services. And there are a handful of components that we'll be talking about today, probably using acronyms like PE and VP and things along these lines. So just a very brief recap of what the virtual volumes framework looks like. We have a data store. We have a protocol endpoint, which gives us access to that data store. With the protocol endpoint is really this is a very treacherous path I'm walking here. There's about a 5-foot drop. There's a protocol endpoint that gives us an I/O path from a virtual machine to the virtual volumes that reside on the array. That protocol endpoint is really the proxy through which all of the data will travel. We have a VASA provider, or VP, which we talk about. It's the management channel. The VASA provider gives us the ability to offload any types of commands for storage onto the arrays to do things like snapshots and create VMs and clone them and so on and so forth. So we have out-of-band management through the VASA provider. We have a data path through the protocol endpoint. And then we have virtual volumes themselves. The VMs in a VVol architecture consist of 5 different types of objects that will reside on the array, but fundamentally those represent the virtual machine. And we'll be talking in more detail about all of these things as we go. So I guess first thing I'll do is just throw it out there and say, have I clarified that enough to your tastes? Anybody want to expand on what the virtual volumes framework is and what sort of things it can deliver to our customers?
Yeah, I mean, I'll start. I think for us, I think there's 2 main components that are really important for virtual volumes. Think of VMDK-based storage and policy-based management. So I think virtual volumes, you got to think of those 2 constructs. Policy-based management is going to be the framework to help you drive that automated private cloud infrastructure via service catalogs or otherwise. And then the VMDK-based storage is just going to help you drive towards a higher level of efficiency in infrastructure that you can't achieve today. So as long as you remember those 2 key concepts, that's where you should start.
What do you think the biggest benefits of virtual volumes are? What are your customers, what's the interest that's being expressed to you from your customer base about the virtual volumes framework, and why is this something that people are excited about?
I'll start. Okay. So virtual volumes is really another addition to VMware's fruition of their vision of being able to provide a zero-touch data center as much as possible and a software-defined data center. Now, we know the term software-defined data center gets used a lot, but at the heart of it, what it really means is that software defines and hardware intelligently delivers. What that translates from the storage world is if I am building a workload, rather than build from the storage up to the workload, I can take the characteristics and needs of the application, whether they be performance or resiliency or protection based or whatever, wrap a policy wrapper around it saying this is the policy that contains all the characteristics, and then automagically the software, meaning the different pieces of software that talk together, some in the vSphere kernel, some in the array, they communicate together through a control path, and automatically the VM is placed on the right storage on the array. So VASA being the ability for the array to communicate its capabilities to the vSphere, the storage policy business manager being the engine that delivers the software-defined capabilities to the app, and then the endpoints being, the protocol endpoints being the path that goes to the data itself. So together they make a system that frankly works very well. So what our customers are looking for, to answer your question directly, is they've always been looking now for a while, for maybe about like last 3-4 years this has accelerated. They're looking for ways and means to cut down the time that IT spends on keeping lights on and fighting fires. Those kind of things usually come from manual configurations, one-offs, siloed infrastructure. By putting your workloads in a policy-based infrastructure, you can now go ahead and actually cut back that time, make it available again to the administrators so they can actually be more innovative with their time and provide more benefit to the business. Remember, the business is not in the business of building LUNs and RAID groups. The business is probably in the business of selling some services or widgets. So this is just a means, it's not the end. And if we can automate and orchestrate this in a software policy-based fashion, we get a lot of benefit from a storage perspective.
All right, so maybe a shorter answer. I think for our customers, there's two benefits. There's technical operational benefits, and then there's using this as a foundation to help them get to their next generation infrastructure going forward. So we look at some of the technical benefits. There's things like removing unmap issues, removing issues with VMs, locking on data stores, simplifying multi-pathing in the environment. There's technical operational improvements that make a big difference to customers, or even getting away from VMware-based snapshots to using snapshots within the storage array itself. But the bigger benefit for the businesses, these businesses want to become an internal IT service provider within their own data centers versus the shadow IT going out to Amazon. And virtual volumes and SPVM really gives you that framework to help you build out your internal IT service provider infrastructure, helping the VM team and the storage team really virtually collaborate through the VM storage policies and capabilities so they can actually build out VMs and scale their VM services as effectively as the Amazons of the world. So.
To build upon what Paul said and even shorten it further, I know when I speak with a customer that they've got it, when they start using the word granularity, all of this VVols and all of the terms, storage policy-based management, we've had for a few years, but they've always been per volume, per data store. You now get it down to per VM, and in some cases per VMDK. You get to split that virtual machine up and say, the C drive is going to have this policy. It's only the OS, so I don't care what disk it's on. But the data drives, they need to be on high performance disk, or they're containing sensitive data, so they need to be on encrypted disks. So you get to break that virtual machine apart and assign different policy profiles to different parts of the virtual machine. That's a big part of what Vball is providing you as a customer at the end of the day.
Perfect. And I want to emphasize as well, this is your session. We have the panelists here from all of our design partners in the Vball space. I've been asked questions all week about specific details. How do you implement this? What do you do in terms of VASA provider availability? Things along these lines. We have microphones. We're happy to take questions throughout the session. So by all means, throw your hands up. We'll spot you in the audience. We'll get a microphone over to you as the questions come in. And in fact, we have the first one here already. So by all means, let's.
I'd just be interested to hear from each of you regarding recommendations or best practices regarding storage containers. One per array that present all of the capabilities, or do we split the array into separate storage containers for different purposes? That kind of stuff.
So that's going to largely be vendor specific and how they implement it. I know in our case for EqualLogic, so we don't give you that many buttons and dials to play with. So you get to create that storage container. You can create multiple storage containers, but that storage container is going to bubble up all of the capabilities of its underlying storage. We've discussed the possibility for some of our other platforms of, well, maybe we want to turn off certain features. I'm a storage admin. I'm a bit paranoid. I want to only let the vSphere admin have certain choices. Do I turn off and on features that I don't want him to be able to use at the array level and deny him the option of choosing certain capabilities? It's something we've discussed internally. We haven't decided on what we're doing on other non-published platforms yet.
So,
sorry, please go ahead.
I was just going to say, so one of the concerns that I've heard with all of the partners that have looked at Vballs is, so I have a shared array. I'm using that array for regular, ESX data stores, Oracle, whatever else. And if I put Vballs and give the Vballs, a storage container, what happens to my space on the array? Can the Vballs VM admin go crazy and create, a ton of VM, chew up all my space? So on the 3-part side, you can slice and dice this, very, very granularly. You can give the whole array as a storage container, or you can limit the VM admin and say, I'm going to just give you a specific amount of sort of capacity, and say that's all you get as far as Vball is concerned. So it's very granular that way. It all depends on the vendor implementation, and so everybody's going to be different.
I think we should maybe even clarify what the storage container is and what that looks like. When we have an array, we can subdivide that into different components in terms of capacity, which we call storage containers. And they're a purely logical entity. And I guess the question is, what's the best practice there? And the answer is, there isn't really a best practice. It comes down to those requirements. Is that a safe summary of what?
Yeah, I think that's pretty fair. I think one of our customers, they're in a multi-tenant environment. So for a multi-tenant environment, they want to have a separate storage container. And as you say, a storage container really is a virtual construct. Conceptually, you could have one Vball data store, which equals a storage container to manage your whole environment, and that's pretty powerful. But depending on multi-tenancy requirements or security isolations, you could certainly add more. But certainly, one Vball data store, you could certainly go.
I can give a different perspective, a higher perspective. What's the most important for you? More data to manage, right? Less and less time. Where do you want to spend your time? Creating LANs, creating NFS shares, managing PEs, managing Vballs? You don't care. What you expect is a tight integration between vSphere and the storage. You want and you expect that if you buy an expensive storage with a set of features, you want to use them. You want to control them, but you don't care how to implement them. You don't care how slicing, you don't care about thread anymore. It's a basic. You don't care about dedupe, that's a basic. You don't care about compression, that's a basic. You don't care about the protocol, you want to have the choice, the best one. Which is the best one? So what Do you expect to, oh, shall I go fiber channel, iSCSI, NFS? You don't care. You just want the best of what you just bought, right? So the expectation from my customers are, do your job. As a working companies together, we know the rules. Of course, we can explain how it, what's the most important for you? Is running fast, protect your data, and make your app users happy. So what if you change job from, I'm creating LANs, and you have an app guy coming to you. I need 1 terabyte. And you spend your day doing your slicing, your red things, and discussing, is that a virtual space, or a SIG space, or SYN space reclamation? You don't. Is that interesting anymore? No. You want to go to, I'm managing the storage. This is my data policy. What type of gold, platinum, hyper secure, less secure? But then you don't care. You rely, and this is about it. It's moving to a service level. Storage is no more about LANs. It's no more about shares. It's how you service your data. So it's about us providing to VMware team that type of service you can use, and you moving up in the stack and doing architectures, but not storage architecture, business architecture. Because if we don't move them together, we are all dead. Cloud is not about LANs, it's about business. And it's a very important shift in the IT. And my customers say, and they see it, now IT is a business enabler. So if we build together, do not allow you to move in that direction, we have to change job. So that's key. You understand feed and speeds, but it's key. The app orientation is going through.
I think
automatically.
Highlighting a perfect and very, very fundamental aspect of the virtual volumes framework is that this is all about policy management.
Right.
Really the architecture, and we're happy to talk about the details and the implementation specifics, but it's all about changing the way we consume that storage to this policy model. And in terms of those policies, of course, we have representations from different vendors here. The types of policies that we can use for our virtual machines can be extremely broad and very wide and very detailed and sometimes very simple. But the point is, yes, it lifts it to a different conversation where we're talking about managing VMs at the application level rather than at necessarily the storage layer. Is that a fair summary?
Absolutely.
Perfect, yeah. There was another question down here in the front as well.
Currently, multipathing are implemented at the protocol endpoint level. So what should we do to maximize the performance? Should we use a round robin policy or third-party policy or create multiple protocol endpoints?
So want me to take that? So it all depends again on the array vendor. For 3PAR, like you said, multipathing happens at the protocol endpoint level. For us, we say switch it to round-robin pathing and you're good to go because all the Vvols behind that protocol endpoint inherit the multipathing policy that you have set on the protocol endpoint. So round-robin pathing works for us. You'll get the best performance. You're good to go.
So in general, at least in the EMC landscape, round-robin works best too, unless you want to use something like PowerPath. But honestly, we haven't completed our testing of PowerPath against Vvols yet. So we hope to get that done early next year, in which case our answer may change. But today, as far as native multipathing is concerned, round robin is best. Having said that, it depends on the kind of array and the array's architecture too. So if I have an array with, let's say, active-active data controllers, round robin makes total sense. It's like a no-brainer. But if I have something in an active-passive manner, I may want to at least consider experimenting with other multipathing policies for certain workloads. The problem with that is the whole point of Vvols is to get away from the mechanics of the storage delivery to the consumption of the storage delivery. So round robin, if I set Alua mode 4 on my controllers, round robin works fine. So set it, forget it, go on with your business. That's the way I would recommend it.
Yeah, I mean, that's pretty good. The only thing I would add, I guess, from Hitachi implementations, most questions I get on protocol endpoint around, do I need multiple because I need for queue depths? And so for the Hitachi implementation, there's no queue depth on the protocol endpoint itself. It's the actual Vvols themselves have the queue depth. So one protocol endpoint can satisfy an environment and using native multipathing. And that's really what we're trying to reduce the operational involvement in enabling Vvol.
I will re-emphasize this QDEF. I mean, we've done fiber channel for years all together. Okay, QDEF is the thing. How many commands can you send? So, and this performance perspective is interesting. What if you have VDIs on your VMware, right? You want to boot how many users every morning? Then you have a big demand in terms of IOPS. And it's not rare those days to have 100,000 IOPS within below 1 millisecond to sustain immediately. And then you touch the limits. Because when you move from hard drive to SSD, whatever flash you're using, it's a different story. The type of streams, the optimization for performance is not the same. If you're running a test, if to test your array or your PEs on a hard drive, you will never use the same one to test your SSD, right? To get the max performance. So moving from LANs to NAS to PE, it's the same. How many commands can I send? Do this array, do this architecture can sustain 1,000 IOPS per pass? Do I need multipath passing? Not for resiliency, but for performance, right? So here it's a tricky thing. There's no generic rule because there's no generic application. That's where it's a combination of all roles to say, okay, maximum commands, we expect perhaps 4 paths to sustain performance, right? It's just, we end up to the same questions we had in the past with fiber channel or the protocol, right? So it's an architecture endpoint you have to take care of if you move to performance side, especially if it's all SSDs, then you need to think about it. My Unix background is telling me the more you have is the best. The more you stripe in the front is the best. The most QDEF and the more flexibility you have.
That actually brings to mind another question that always comes up for me, performance with Vvols. People always say, oh, well, is it better? Is it worse? Is it completely different? What's been your experience in terms of that aspect of a virtual volume-based VM contrasted with a traditional type of VM? Have you seen a difference? Anyone?
So performance is always a touchy subject because, as with anything, you carefully choose your benchmark and you can skew your results whichever way you want. But like for like, which is the only way you can fairly do it, we're definitely seeing an increase in performance with Vvols. Whether that's, I haven't personally dug into it, but whether it's down to the lack of the VMFS layer, whether it's down to now more direct paths down to the individual data blocks because of Vvols. I'm not that technically in depth on an infrastructure like that, but there's definitely a strong, as an end user, you're going to get more performance out of the same hardware.
Right.
Yeah. Another important aspect too is around performance is with VMDK-based storage, indirectly you get better performance because you can be very specific in the resources that VMs get within the infrastructure with policy-based management. So indirectly those tier 1 apps that need higher performance or role instantly will get it because they're very efficient utilization of resources in the infrastructure, certainly with the Hitachi implementation as well. So the answer is yes, but indirectly.
I'll give a different perspective. I think it gives more flexibility, at least in a NetApp array. If you know NetApp, we are manipulating the backend FlexVol object. It's let's say object type of storage. It depends on the protocol. When you had VMDK, the limitation with VMDK was performance. It was sticked on a LAN. So we all have virtual storage now, virtual arrays. So you could span your LAN on many spindles. But again, you may have reached some other limits. The thing with the Vball is abstract completely the array. So in terms of NetApp, eVball may be a different set of FlexVol. So you may span your storage with Vball across multiple arrays. So it gives you more perspective in terms of evolution for your platform. Again, I think we all like it simple. You know, we always apply the 20-80 rule. Spend 80% of your time in 20% of the problems, but you want the 80% things running fast, just easy. So it's a lot of time to tune the things, but for fewer applications. So the work we are doing together is make you happy, spend 20% of your time managing 80% of the things, and spend more time, and you will still spend them on performance tuning, aligning the things together, because you have very specific application demanding very specific type of latency and performance.
So the human performance improves.
Yeah, I would agree with my colleagues. Performance is always, the problem is the way you measure it is shifting.
Of course.
Dramatically. And it's very tough. The question I ask my customers, how many IOPS do you want? I don't know, fast. What latency? Fast. What's your working set?
Big.
Your what? Working set? You know what a working set is? You know what a data set is? The same with Vball. So how much in memory? How much do I hit memory hit? So, and you add to this, moving to SSDs. Electronic is completely different from drives. So the way you maintain the load, you go below the half millisecond latency, is completely different. Some application may never go there, and you will be upset. So yes, it's really tricky, and what we see is we spend more, our specialists spend more and more time on performance design, not architecture, performance design, you know, the tricky things.
So in all the internal testing that we've done at HP 3-Power, yes, VVol's performed slightly better than VMFS data stores, but that is probably not going to be your driving factor of deciding whether you want to move to VVols or not.
Yeah.
Yep.
For 3-Power, at the end of the day, whether you have a VMFS data store or a VVol, they're the same object on the back-end 3-part array. We don't make a distinction saying, hey, you know, this is going to be a storage container, it's going to contain a Vball versus a regular volume. They're all volumes to us on the back-end array. And because the way we do striping on the back-end array, we utilize every resource in the array. So whether you have a VMFS data store or a Vball container on the back-end array, it makes no difference to us.
So my take is a little bit of everything that's been said. The underlying factor is that it's not about how can I optimize the performance for a workload as much as it is, can I provide good enough performance for the workload in a consistent manner? And if I can do that programmatically or automatically through a policy-based management system, then I'm golden. The whole point is zero touch. Like we said earlier, you know, like you said actually, human performance increases, right? So that's actually very true. I don't care if this app gets 100,000 IOPS if it only needs 20,000 IOPS. As long as I know which of my apps need what kind of performance and I can automatically direct them to that kind of storage, I'm gold.
I think also beyond that, though, I mean, you touched on SPBM and storage policy-based management, and I think the one aspect of the granularity, that fine control that we have, is the ability to assign policies not just to different VMs, but to different disks within those VMs.
Yeah.
So where we do have those requirements around different policies for different components of a system, we can actually have those represented very easily without having to worry about the complexity that underlies that storage. So any, I think I saw a question here. There's one right there in the middle of the room, right there with the hand up. Thank you.
I have two questions. The first one is when you change the storage policy on VVols, what happens? Do you have a vol move on storage arrays? Or do you have storage vMotion? Do you have to configure automated storage, DRS storage vMotion? And the second question is, how does the ecosystem is managing vVols, like SRM, like software backups that are able to manage storage array snapshots? Okay.
I'll turn that straight over to the panel.
Okay, so the two features that you're talking about that currently are not supported, those are limitations of the VASA endpoint currently. VASA 2.0 is significantly more advanced and more enabled than VASA 1.0 was. However, VASA 3.0 is expected to be even more so and support most of what you're talking about. Vvols 2.0, if and when it comes out, and I'll let VMware be the authority on this, but from what I've seen on the roadmaps, they have to first, support it. So once VASA supports it, Vvols can support it, then the vendors can go ahead and implement that support.
For Hitachi, I think your second question is snapshots replication. No, our GA code supports snapshots. No. With virtual volumes, I mean, the important construct is the native vSphere snapshots and clones are automatically offloaded to the array. So we natively get that support. For replication, actually, we support replication for DR. So if you want to implement VVols for DR, remote DR replication, that's supported today. For SRM orchestrated recovery plans and so forth, that's coming in the VVol 3 that Raj mentioned. Your first question then was around storage policy-based management and what happens when policies change. So right now, when you assign a policy to a VM, it becomes in a compliant state. When you change that policy, the vSphere APIs will actually bring that VM into a non-compliant state. And then we basically get an API. We can enforce whether a VROL workflow or another workflow to actually bring that VM back into compliance. Like one of the analogies I use with one of our customers that's using it is they enable a VM policy, for example, with tier 1 performance and tier 2 availability with a virtual vault implementation. At certain point in time, they change the policy from tier 2 availability to tier 1 availability. So again, they're basically telling the system, I want to move from a RAID-protected mirrored system to maybe a stretch storage-based implementation going forward. And so in not this version, but next version, will enable customers that move that VVol directly into a stretch storage configuration automatically for the customers. Now, that really is the benefit of the storage policies.
Yeah, I think those policy changes are a very important aspect of the virtual volume infrastructure. You can dynamically alter a VM, well, you can manually alter a VM's policies and the SPBM policies that are associated with any object of that virtual volume. So it's not something that's fixed, it's not something that's static. Behind the scenes, when we change that policy, yes, it's an API call to say we have a new requirement from that VM, and how the array will respond to that request for a changed policy is going to be independent of the VVol architecture itself. That will be specific to the arrays. That makes sense.
Another question.
Let me answer to, if you allow me.
Certainly, yeah.
At NetApp, we are very happy that VASA is evolving to at least cover what we have for many years as features in our array. Automation, auto-grow, auto-delation, all the things we have by nature for years. And coming back to my first point is, if you want those things to be automated, the connectivity, extending a VVol, for you it should be either automated completely, and it's a shift. Many customers of mine say, okay, so I was doing learn sick provisioning. Shall I continue? Why? No way. I mean, all we are doing now, you do thin provisioning, but you had to wait for vSphere 5 to take benefit of it, right? So the good news is it has been ready in the arrays, so depending on our own implementation for years. So expanding, we have many customers going to NFS, right? Why? Because you can expand, decrease on the fly without any migration of data, none. You could automate it completely. So we expect, and we are very happy with this VASA provider here is enabling to more customer what we are doing for years. I can give you a different perspective. Is if you define a policy where it's auto-grow here, the nightmare is, oh, my primary data, my primary storage, that's nice, I can manage it. Now it's replicated in 2 locations. Close one, long one. How do I handle if I'm increasing my volume on the primary? Before doing it, before replicating any space on the 2 other sides, right? So it demands 3 actions on 3 arrays. What you expect, because we are doing that for many years, is if your source volume, whatever it is, or Vball, whatever it is 1. What's the chance of the target to be more than 1? None. It's always the same size. So at NetApp, what we do is we say the target unlimited, no constraint, because the size of the target will be always linked to the source one. So no administration. If I auto-grow this one, I don't need to auto-grow the target because the auto-grow is unlimited. It will never max out the source one. So what you expect from those things together is, oh, this is a nice policy. If I'm doing auto-grow there, then it auto-grow the target, done. So we are happy here because we are trying to reach what we are providing to our customers for years. So that's a good thing for more customers. Yeah. Nice feature. Again, you move up the stack.
There's a question there, I think.
Actually, I have 2 questions. First, we're still talking SCSI. So and you mentioned the queue. In traditional architecture, you have a relation from the queue to the queue depth of the LAN, so that you know how performance is, if it's working or not. Is there now a direct connection between the queue on the host and the Vball, the container on the storage, or how can I deal with it? So usually I know there's best queue is 32 per LAN, then the storage are usually working quite fast. So now I'm missing this relation. Is there a 32 queue for each Vball container?
So you're asking with regards to the change in handling of queues and paths and things along these lines, where traditionally that was a function of the LUN. Whereas now, does each Vball get its own queue? What is the protocol endpoint and what's its role in handling that?
Okay, from a Hitachi perspective, so when you look at the SCSI, basically the virtual volumes is the secondary LUN ID. So the protocol endpoint is your endpoint. There is no queue depth on the protocol endpoint. With our implementation, the I/O comes into the protocol endpoint. We have an ASIC in the G1000 that redirects the I/O to Vball that's targeted as part of that LUN ID. So the queue depths are really on the VMDK Vballs within the storage, and they're still your native 32 queue depths, and that's static. But the protocol endpoints, it's unlimited queues because it's really a proxy LUN is what it is. So.
Sorry. So ultimately, you've gone from having 1 queue depth per volume to having now multiple queue depths per virtual machine, and that's one of the angles where you're getting that performance gain from.
So on the 3 part, the queue depth number still exists, but that number has been increased so dramatically that you're probably never going to hit it really in production. So that becomes literally a moot point for worrying about queue depth issues on the individual Vballs.
Yeah, I kind of agree. The limits we have on our array now are so high that, again, it may represent 1% of the cases, but we have to figure out. And another perspective on it is, yes, virtualization adds complexity. At the beginning, it's simplicity, right? It covers perhaps 99% of the cases, but then you have to manage that extra 1%, performance oriented. And when it comes to performance, what are doing the performance guru? No GUI, shell. Because what's your connectivity at the end of the day? Fiber channel, Ethernet. So if your fiber channel connectivity backend, it's all about HBA QDF at the end of the day. And it's become tricky because it's multiple streams going there, so it's fiber channel analysis. If you have FCOE or iSCSI at the end of the day, it may...
There's another question there.
Sorry?
Yeah, the second question was, but maybe I can answer it myself, but we'll ask it now. The endpoint is, in Hitachi terms, it's an ASIC on the controller or somewhere else. And if I have to troubleshoot, usually in past times, I took an analyzer, encapsulated the protocol, and had a look at the SCSI level. Now I only can see from the host to this endpoint. Everything what is behind this endpoint is virtualized. Or, yeah, is that correct?
So I'll take this. So on the 3-bar side, even though the Vball is sitting behind the protocol endpoint, on the array it looks like just another volume. So when you want to do on the 3-bar, you can look at stats on the 3-bar per individual volume. Whether that volume is presented as a VMFS data store or as a Vball, you'll still get the same stats, same commands on the 3-bar to look at those things. You might have to add a couple different flags to say, hey, no, I'm looking at a Vball thing, but otherwise, you're looking at the individual Vball on the 3-bar array if you want to look at performance.
So to build on that again, your virtual machine is now a group of volumes on your array. Your existing array tools that told you, the I/O performance of that volume now tell you the I/O performance of the group of volumes that make up that virtual machine. And depending on how your vendor has implemented it, they might tell you the D drive of this virtual machine is this volume on the array, and this is how many I/Os it's doing. So the problem that virtual machine is having is the malformed SQL query that your DBA wrote, not the storage, not the virtualization layer.
Yeah, exactly. I think the storage admin team now have better visibility. Before, you have to work with a data store, but the storage admin team now can actually work with the VM, VMDK. They've got visibility to the VM. So when that call comes in about a certain VM and Oracle VM has issues, the storage admin team has actually visibility that this Oracle VM is using this VMDKs within the storage infrastructure itself. So they can quickly answer whether it's a VMDK-based issue within the storage, whether it's using native Hitachi tools monitoring the environment, or VROPs, for example, using VROPs to get topology information. You get better visibility to help you virtually solve that much quicker in the environment.
Do you always pick on DBAs as well?
No, they're good. I like it.
You're going to say something?
No,
okay.
They've already said
There
everything.
was a question over there, I think, as well on the end. Yeah, that's one of the nice things, is giving the visibility that's appropriate to the right people.
Yes.
It's kind of
It's that granularity story again.
Yes, perfect.
Actually,
Yeah, that's on.
I have 2 questions. Number 1, how does the migration path to Vbols looks like? And number 2 is it production ready?
So to answer the first question, it's a storage vMotion. So a couple of clicks, go have a cup of coffee and you're done. The second story, it depends. Do you need replication and SRM integration? If you need those, the answer is then no for you. If you can live without replication and SRM integration, then you can start using it today.
So, first, I agree with David 100%. Whether it's production ready or not will really depend on what you deem as a production ready technology. What I can tell you is that what we are seeing across the customer base that we have, people are still testing it out. So, and it's linked, I mean, you can't help but link it to vSphere 6. You need vSphere 6. And you know and I know that every time a new version of vSphere comes out, it takes a while for people to kind of implement it, right? Usually they're running 1, maybe 2 versions behind, maybe 1.5 versions behind. So most people that, there are customers that are playing with it today, but most customers are waiting for like vSphere 6.1 and see if what they deem as production ready features can be implemented or not. That's, as far as replication and SRM and NFS4 and IP6 and all those things that VVol doesn't support today, they're far out in 2016. Well, yeah, 2016. They're far out in 2016.
You never say a year.
No.
You could say May. You just can't say 2016.
Yeah. They're on the roadmap, but roadmaps will change all the time.
So I think they had, sorry, Rich.
Yes, let me finish. So just know this, look at your workload. And if your workload fits the profile that Vvols can satisfy today, it's a fantastic technology. I don't see anything about it that is not quote-unquote production ready. However, it depends on the features of the workload that you require.
So the Hitachi answer is slightly different. Now, we are shipping GA code today for both Fibre Channel and NFS. Our customers are seriously looking at it in their environments right now, because if you look at virtual volumes, and it's going to be a coexistence model for a period of time. You're going to have VMFS, NFS, and VVol implemented in infrastructure. Our customers are seriously looking at running this on tier 3, tier 2 right now with the stuff we have right now. The second aspect was around how do you migrate, and really is the storage emotion really is going to be a non-disruptive way to move from VMFS, NFS to VVol-based implementation.
Yeah, I'd echo some of the similar comments that were made here. So vSphere 6 went GA in March of this year. Vvols is part of vSphere 6. From a 3-part perspective, we are the Fibre Channel reference platform. All the customers that I've talked with that have looked at Vvols, they're waiting for replication to be added before they really start diving into Vvols heavily. People are playing with it, they're kind of getting their hands wet with it and seeing how it looks and what it feels like. But until array-based replication is going to be integrated, people are still holding off of moving into production with Vvols.
Sorry, please go ahead.
I think it's understandable for customers to be hesitant about moving to Vvols. It's a big change in the storage architecture, top down the entire way. How do I manage this change? There's such a shift and change in the storage architecture in terms of, we used to talk in vSphere 3, how many virtual machines do I put on a volume? Those questions are thrown out. So what are the new questions? There has to be new questions. So how do I build my environment? How do I architect my environment? I can't just blindly trust my storage vendor. Yes, they're great at communicating things, but there's always those niggly little points that affect somehow in my environment or somebody else's environment. And Vvols is so new that it's hard to say that it's all going to be wonderful, rainbows and unicorns. It's going to be a learning experience for us all, and that's going to happen as we migrate from VMFS and NFS to Vvols over the next 2 years. It's an emerging technology.
And I agree with my colleagues here. Yes, it's ready, you can use it. 2 perspectives. The first one is the discussion we had about performance, the P thing, how do I monitor? So array per array, you have to get used to it, new type of monitoring. And the second question is, why would you move to Vvol? If you move to Vvol, it's not just to change from VMDK to Vvol because that's new. You expect more from the vSphere layer, new features, new way of, so it's a big process change. It's not just a tech change, yet another one. It's, to take benefit of all the whole stack, yes, you have to start with Vvol, but if you don't go up the stack, is that worth it? I don't know, I'm not sure about it.
I would
Spending
absolutely
the time just
say,
moving from Fibre Channel to NFS, wow. What's the benefit? So first, what do you expect as a new way with VMware? And then go to it.
that's the critical piece, I think. It's not just the technology implementation details. It's SPBM. It's a different way of consuming storage. It's a different set of questions entirely, not just for the storage administrators, but for the vSphere administrators, for the application owners. What policies do you want to deliver to these VMs is the big question. And if you don't have an answer for that, there's no point even in poking at the technology. It just becomes an intellectual exercise at that point more than anything else. So those application owners need to be involved. The vSphere administrators need to be involved to know that you're going to receive the benefit. There's a question there. Yep.
As far as I know, SAN backup is going to be a problem with the Vballs. Is that correct? And if I'm correct, will it be changed in the future? SAN-based backup, so you back up through another machine.
Backup. So how do backups change fundamentally in a Vball architecture? Is that the question? Okay.
At EMC, we've tested our backup technologies that are available today. And what we've tested and what works is the ability to back up a Vvols-based VM and rehydrate it. So that does work. The more important question is, how do I take what Vvols offers, which is business logic for applications, storage-based business logic for applications. How do I take that and attach that to backup? And that could mean different things. So it could mean that when I build a VM, just like I have replication requirements, performance requirements, I may also have backup requirements. So when do my backup technologies start bringing that ability into this framework where I can add it to the profile that I'm building? That at the EMC is, it's on the roadmap. It's, again, you don't know for sure, but because things can shift, but it is currently hoped to be able to provide that next year on our backup products. As far as the product working with a VM that is running on VVols, it absolutely works. You can back it up and rehydrate it. It works.
I think two answers. One, VADP still works with VVol, but I think ultimately this is an opportunity to actually transform the backup process, because we see customers actually moving towards a snap, replicate, archive, and like a copy management process for backup with VVols. So we believe that's what we're delivering towards with our solutions going forward, is snap, replicate, archive type backup process.
So Dell's vRanger product goes GA for support for VVols in mid-November. Veeam, the competitor to it, has already released. I've spoken with customers who've used both, and in terms of the impact to I/O when vRanger or Veeam is taking that VMware snapshot, they're seeing a dramatic reduction in the impact to the I/O performance. So VVols is helping out there in the existing backup tools, so they're going to work, but they're going to work better now. I think there's a great opportunity for some of the other backup products to, because now a data drive is a volume on the array, how can I maybe manipulate that in the future in terms of getting better backups? I think that's something that the backup vendors are looking at, where previously this data drive was buried inside a volume on a VMDK, now it's a volume on the array. Is there the potential to mount that volume and suck the data off it directly without going through the vSphere stack, through the virtual machine, but just grabbing it directly off the host? I think there's some creative work being done there by some of the backup vendors.
So on the 3-bar side for backups, you can take snapshots to your heart's content. Some of our products that we have, the Recovery Manager Central integration, for example, or the Data Protector integration, we're adding VVol support to that. And then at the end of the day, it's up to the backup vendors really to add support for VVols to take the snapshots and then back them up.
So at NetApp, the good news is there's no change. Why? Because for a bunch of years, we don't care what you store for VMware. Meaning that it's like a VMware platform. Storage is virtualized. You service data. If it's a LAN, it's a LAN, but it's a fiber channel service. If it's a file, it's an NFS or CIFS service, right? And snapshot technology at NetApp is what makes the value of NetApp. I have customers running 70,000 snapshots on an array without penalty. For years, why customer move on NetApp for VMware? Because of snapshot. Because we don't use VMware snapshot. Why? Because it's a pain in the ass. Sorry for that, but. So what we built with vSphere is a plugin. So when you do a snapshot, you don't do a VMware snapshot, those copy things, etc., because it demands a lot of IOPS. We ask for a NetApp snapshot directly. Look at Veeam 9. The beauty of it is you plug in Veeam, you do a VM snapshot. It does not do a VMware snapshot. It does an array snapshot, an array replication, an array snapshot protection for years. And the impact on production is zero from the DNA of NetApp from the beginning. So moving from NFS, VMDK on fiber channel, VVol, it's the same. For years, we have many customers running thousands of snapshots on the primary without disruption today.
I think
so it won't be any change. And we are going further with more simplicity, and it's all about,
And with the VVol, with the VVol architecture, I think the impact of snapshots is negligible across the board now, which is really nice. So even though we have different transport methods that we use with things like VADP, things like SAN transport don't make sense anymore. But things like HOTAD become absolutely marginal in terms of the impact of the performance and so forth. We got about 4 minutes left for any other questions. There's another one right here. There's a gentleman right here who has a question.
Just a little question. I saw on another VMware product that is doing hyperconverged solution that they implement L-check plugin in order to test the configuration. So does vendors are creating for each Vball, for each VASA provider solution, an L-check plugin in order to test, for example, that for NFS we use jumbo frames. We have for the SAN the multipassing right configuration for the storage array and so on. And are we able to create a higher burst test for the storage in order to be sure we can handle the performance? Okay.
So I think a short answer. Before the session, I just tweeted basically best practice paper on how to implement virtual volumes on Hitachi, and it touches some of the aspects of those questions. So I think have a review of that, and you'll see that'll definitely answer your questions. The short answer.
Yeah, I think the testing frameworks and again some of those best practices, as mentioned earlier, this is an emerging thing. So getting some of those use cases is still a work in progress for all of us, really at this point, and how you would go through and analyze the every possible permutation of configuration that you would have. That said, again, specifically things like jumbo frames and so forth, that will impact network-based storage more than it will impact something like a fiber channel or whatever it would happen to be. So we would have to take a look at those individual requirements that you're looking for and come up with some solutions for you for testing. So there's one further question at the back. I think we've got time for one more. The gentleman there towards the middle of the back of the room there. Oh, perfect.
Thank you. A short one. Can we expect to see Vballs combined with NFS 4.1 and multipathing?
Just repeat it one more time.
Yeah.
Vballs combined with NFS 4.1 and NFS multipathing?
Oh, VMworld with NFS 4?
Yes.
4.1 NFS.
You can't
You
expect
mentioning, sorry, PNFS, is that correct?
No, the NFS version 4 is not supported today under VVols.
It's not supported now, but can we see it?
I'm not sure about the roadmap for that, honestly.
It's a high priority item for us, absolutely. Yeah,
Well,
that's, I think all we can say at this point, but yes, that's coming. So, sure, we'll take one more question back there, and then I'll wrap it up.
VVols, like all other features, the most features based and configured on vCenter. And what happened if we lost vCenter forever? What happened with virtual machines based on VVols? And can we retrieve VVols information at new vCenter? Is it point of failure or not?
So there's a chunk of metadata about a virtual machine that's stored on the array. So you should be able to lose your virtual center, lose your VASA provider if it's not built into the firmware like some of the vendors have, and rebuild your environment, rebuild your virtual center, rebuild your VASA provider, and continue running. While you're down, you're going to lose all the features of virtual center, obviously, because you've killed it. But your hosts are going to continue running I/O. Your virtual machines are going to continue running. But you're going to lose a lot of management because you don't have virtual center and you don't have your VASA provider. Once you get those back in, the metadata is going to repopulate back from the array. Assuming the metadata has been stored on the array, the VASA provider protocol, if I'm using it correctly, the term, doesn't necessarily call for that. So in some cases, the metadata could be stored somewhere other than the array.
So fundamental, sorry, we can jump in on that. I think fundamental to the architecture, yeah, it's like any other type of an environment. If we lose certain components, we will lose some manageability, we'll lose some visibility, but it's not going to impact running virtual machines. And we're working with our partners to help enhance that story even more, absolutely. This is not a spec that we've released and then we're sitting on and saying, there you go, I hope you like it. This is really fundamental and important technology for us and for our partners in this industry. It really is a change. Expect really great things, and I hope to see you next year at the next Virtual Volumes technical panel. Thank you, everybody. Thank you for joining us. I really appreciate it, and thank you for the questions and interaction.